Alright, so integration of trig functions. So we've already covered differentiating trig functions, and we went through these rules in the last lesson, and I gave you in class today the table of standard integrals, which has these three integrals on them. So you can use them to either go backwards to differentiate. The derivative of sine is cos, the derivative of cos is negative sine, the derivative of tan is sec squared, or you can use them to integrate here, going from left to right. And you can see that now, when you're integrating cos of ax, we have to divide by a, or times by 1 on a, where a is the derivative of ax. Okay, likewise with sine integrates to cos, and we've got to divide by whatever the derivative of ax is there. Now, sine, handily, really coolly, stands for sine integrates negative. Pretty cool there. So if you forget to look at your standard integrals, that's a handy thing to remember, because the derivative of cos is negative sine. So the integral of sine is negative cos. Okay, so let's look at some. Find the primitive of. So that means integrate sine of 2x. Alright, so the integral of sine 2x is, we can write it like this, sine 2x with respect, sine 2x with respect to x means we will write sine 2x, integral sine 2x dx. So we're going to have to, remember sine integrates negatives, it's going to be negative, and the integral of sine is cos. We're going to keep the angle exactly the same, 2x, but we're going to divide by, or times by, we're going to times by half, or we're going to divide by 2. Okay, because that's the derivative of 2x. And this is an indefinite or primitive indefinite integral, so we're going to plus c. Alright, then we're going to find the primitive, or the indefinite integral of sec squared 4x plus 3. And that's going to be, well, the derivative of sec squared, the derivative of tan is sec squared, so the integral of sec squared is tan. And we're going to keep the angle, 4x plus 3, exactly the same. And the derivative of 4x plus 3 is 4, so we're going to divide by the 4. And it's indefinite. In indefinite integrals, we're going to plus c. And remember, we can always check our answers integration by differentiating. So if we were to differentiate cos 2x, you would get negative sine 2x, negative 2 sine 2x, and then those 2's cancel and the negatives multiply together to give a positive. So you get back to the question. Likewise, if we were to differentiate this one here, the derivative of tan is sec squared, and we'd have to put a 4 out the front, and then the 4's cancel. So you're left with sec squared 4x plus 3. Alright, so this question here is slightly harder. Let's have a look. The integral of sine of x on 4 dx. Now remember, sine integrates negative, so it's going to be negative, and we're going to have a cos. Keep the angle the same. Now remember, we have to divide by the derivative of x on 4. And the derivative of x on 4 is a quarter. So we're dividing by a quarter, which means it's like this. Dividing by a quarter, and plus c. It's indefinite, but really that means when you're dividing by 1 on 4, it's timesing by 4 on 1. So it's going to be negative 4 cos x on 4 plus c. Alright, now in question 3 we have a definite integral, because you can see that we've got the limits here. It's exactly the same, but we're not going to have the constant of integration. We're going to have to sub in these values. So let's integrate cos of 2x. Well, integral of cos is sine 2x. We're going to have to divide by 2 there, and we're going to put our limits in of pi on 4 and 0. Okay, then we're going to substitute those values in. So it's going to be half sine of 2 times pi on 4, which is pi on 2, minus half sine of 2 times 0, which is 0. Sine of 0 is 0, so that's pretty cool. This whole thing becomes 0. Sine of pi on 2. Well, you can either think about the unit circle or the graph of sine. Let's draw the graph of sine. There we have it. The period there is 2 pi, so that value there is pi. So just there is where pi on 2 is. So sine of pi on 2 you can see is 1, because the amplitude is 1. So we've got here half times 1, which is half. So the value of that definite integral is half. And that's the same question. Alright, another question is applying what you learnt in the topic on integration to trig functions, such as finding the area under a curve. So if we're finding the area under the curve sine x, that means we're finding the area under this curve, and and remember the period of sine x is 2 pi, so that's going to be pi there. We're finding the area between 0 and pi, so that means we're trying to find this area here, and the amplitude is 1. Alright, so to find that area is equal to the integral of sine x dx between pi and 0. Now remember, sine integrates negative, so the integral of sine x is negative cos x between pi and 0. And because it's definite integral, we're going to sub in those values. So we've got negative cos of pi minus negative cos of 0. And cos of pi, alright, let me just quickly draw a cos curve, a cosine curve. Oops. Okay, that value there's 2 pi. Just there is pi. There's 1, and there's negative 1. So you can see cos of pi is negative 1. So that's negative 1 plus, and then cos of 0 you can see there is 1. So that's equal to negative 1 is positive 1 plus 1 equals 2 units squared.